Hello everyone, welcome to Kids Auto and Truck Repair. Today we have a 2010 Honda Element with a 2.4 liter engine. The customer complaint on this vehicle is the check engine light remains on the dash while the engine is running, and the customer also stated that the vehicle is losing power. Now, the owner of this vehicle is one of our subscribers here on our YouTube channel. His name is Mike. He drove about an hour to get to our shop. So Mike, thank you for bringing business to us. Mike told us that this vehicle was fixed by, I believe, another shop. They replaced the VVT solenoid filter to try to fix this. So something is going on with the VVT system. And then he told me that sometimes when he's driving down the road and if he hits a puddle, the engine loses power. So I don't know if it's the ABS system that's acting up. He told me that the VVT solenoid and filter was replaced at some point. So that's all we know. That's good information we should keep on the back of our minds. So now let's go in the vehicle so we can confirm the customer's complaint. Let's see if the check engine light is going to remain on the dash. And after that, we're going to get the scan tool connected. So now let's go in the vehicle. So as you can hear, the engine is running and the check engine light remains on the dash. So customer's complaint confirmed. All right, so we have confirmed the customer's complaint. So now I'm going to turn off the engine. I'm going to turn the key on. I got the scan tool connected to the vehicle. I'm going to bring it up. So let's scan the engine computer and see what we got. Let's see what codes we have in the engine computer. So this is a Honda. Now the engine sounds good. We might have to test drive this vehicle and see what happens. So right there, the scan tool has identified the vehicle, 2010 Honda Element with a 2.5 with a 2.4 liter, not 2.5. So let's scan this. This is gonna scan all the control units on the vehicle. Let's see what we got. This is taking a little while. Why is it taking a while to read? That's odd. Usually the scan tool doesn't take a while to read the engine computers, to read the control units on Hondas, but this is, I wonder if we have a communication issue. It's taking forever. Whoa. How long does this? That's odd. It took a while for the scan tool to read the control unit, to read codes out of the engine computer. So we have code P2646. It says rocker arm oil control system A bank 1 stack off / switch circuit voltage, switch circuit low voltage. Interesting. Rocker arm oil control system A bank 1 stack off. This could be an issue with the pressure switch. I believe on Hondas they have a pressure switch that watches the oil pressure that goes to the phaser or the VVT system. There's a switch there. So when that system is activated, there is a pressure switch that reports back to the engine computer to let the engine computer know that the system is working properly. Okay, and this code can be caused by a switch, like it says, switch bank 1 stack off. So we could have a switch issue or a wiring issue. you know, a oil pressure issue. Maybe we have low oil in the engine. We can have an oil leak that's causing the oil pressure to be lower than normal in the engine, and that could cause this. So now let's read up a little bit about this code to figure out what sets this code, and then we'll go from there. So I'm gonna scroll down and see what else we have. So this code is set in the engine computer as a permanent code and a temporary code. So let's scroll down and see what else we have. 0 codes in the transmission control unit. We have 5 codes in the tire pressure monitor. We have 2 codes in the ABS control unit, battery voltage failure. And then the second code is ECM/PCM relation failure. That's interesting. And then on the generic side of the tool, we have the same code, P2646, A rocker arm actuator system performance / stack off bank 1. So P2646. So let's look up this code. Let's go into the engine computer, troubleshooter, engine, code tips. The code was P2646. P2646. Let's see what it says. Okay, right here. P2646 indicates VTEC oil pressure switch, circuit voltage low. Code set condition: when VTEC oil pressure switch, circuit voltage low. When VTEC solenoid valve is on, VTEC oil pressure switch remains on when VTEC is engaged. Possible causes: low engine oil level, poor connection at the VTEC oil pressure switch, poor connection at VTEC solenoid, poor connection at PCM, short to ground in pressure switch to PCM wire, possible PCM update available, PCM failure. That's good to know. Diagnostic aid: techs in field report that problem is most likely caused by a faulty VTEC oil pressure switch. This is good information right here. So the issue could most likely be the switch. So this is valuable info. I love to have this information, but we're still gonna have to do our tests, okay? These are not silver bullets. We're not just gonna get this information and go under the hood and replace the switch. We have to do some tests, okay? And then OEM part number 3725-PNE-G01 and low engine oil level. Note: to prevent ECM/PCM damage, SCS should be shorted before unplugging any PCM/ECM connectors. To short SCS, select SCS mode from the engine main menu and follow instructions. Okay. Techs in the field have found that an aftermarket oil filter can cause DTC P2646 to occur. Okay, that's good to know. So if you use an aftermarket oil filter, that can cause this code to be set. I guess an oil filter can restrict the oil flow inside the engine, and that can cause that too. So replace filter with Honda oil filter and recheck for DTC P2646. If code comes back, perform normal troubleshooting. So I'm reading over here. Okay, good to know. Now, how should we check this? Now, let's go to data. Let's see if we have VTEC switch data PIDs. Let's go back, because we can watch the data. I mean, this is a 1-bank engine. There are only 4 cylinders on this. If we had a V engine, we could have looked at the data from both banks and compare them to each other, but we can't do that on this one. So again, let's just check out our code once again. Okay, P2646. So that's it. Now let's go to data. So some VVT, fuel and intake data. let's go to powertrain data first. Let's see if we have some VVT system data PIDs here. So right here, VTEC pressure switch, VTC solenoid duty cycle, VTEC solenoid, VTEC status. Okay, let's customize this list. The VTEC solenoid switch, that's what I would like to look at. So let's deselect all these data PIDs. We're gonna grab this guy, this, and that. Okay, VTEC switch, VTEC solenoid. That's all I'm interested in right now. Okay, so let's list these data PIDs. I'm gonna graph the VTEC pressure switch data PID. Actually, I'm gonna graph all of them. I'm gonna start the engine. So let's watch the VTEC, this over here, VTEC switch on. So right now, with the engine off, key on, the VTEC pressure switch is showing us on the scan tool, and then the VTEC solenoid says off, VTEC status is off, VTC solenoid duty cycle is 0%. So I'm gonna start the engine now. Let's see if these data PIDs will change. Okay, so nothing changed with the engine running. I'm gonna rev up the engine. So our VTC solenoid duty cycle is changing. We went from 0 to 44%. And then our VTC status also changed. So the solenoid is being controlled based on what I see over here on the scan tool, but the VTEC switch is not changing. So the data PID over here of the VTEC pressure switch is not changing. All right, so now let's go under the hood. I'm gonna turn off the engine. I'm gonna turn the key on. Let's go under the hood and check the oil level. Let's make sure we have enough oil in the engine. So I'm gonna put this dipstick in the engine first. Then we're gonna pull it out. Now our oil level isn't bad. It's a little bit low, but not much. So the issue is not the oil level here. Now I'm gonna show you the solenoids. I'm gonna show you this solenoid here first. This over here is the VVT solenoid. Okay, this is the VVT solenoid for the cam phaser or cam actuator. And then back here is the VTEC solenoid. I don't know if cameraman Matt can show it to you. So this over here is the VTEC pressure switch. Okay, so we're gonna do our testing at this switch right now. Since we have enough oil in the engine computer, what I want to do now is I would like to disconnect the electrical connector at the switch to see if we have power and ground at the switch. So the way this works is we can look at the wiring diagram and figure out where the wires come from that go to the VTEC switch. I've done this a couple of times. From experience, if I remember correctly, I mean, we can look at service info and read more about how it works. There is power and ground coming to the switch. When the VTEC solenoid opens, then there is oil pressure in that system. The voltage on the switch wire should change when the VTEC opens. So what we have to do is I want to back probe those two wires at the switch. We're gonna use our lab scope and go on a test drive. As we are test driving, when you go on a test drive, when you are driving under load, under certain engine load conditions, the VTEC should open, and as the VTEC operates, voltage on the pressure switch signal wire should change. So that's what I'm trying to say. So now what I'm going to do is I am going to disconnect the switch. Actually, the switch has a lot of oil in it. It looks like this switch is leaking. Matt, can you see this? Let me see if I can lift this connector. I kind of want to get my hand out of the way. Can you see that? Mm-hmm. You see how much oil we have in this connector? We shouldn't have a lot of oil like this. Yeah, you see that? So there is oil inside the switch. Yeah. So we shouldn't have oil in the switch. So that means this switch is leaking. So what I'm going to do is I'm gonna clean the switch, and then I'm gonna back probe these wires at the switch, and then we're gonna use our lab scope to watch the voltage that we have at the switch. Let me grab some brake clean and clean the switch. Okay, good. And then we're gonna use some sharp air to dry the switch. So now I'm gonna use these test leads, our lab scope test leads. I'm going to back probe the wires at the pressure switch. So the switch has got 2 wires. Okay. Now I hope you guys can see what I'm doing. So I'm gonna back probe the first wire, and then I'm gonna back probe the second wire. It's right there. So I back probed both wires at the pressure switch. So now I'm gonna reconnect the electrical connector of the switch. All right, so we're gonna use our long test leads, our test drive test leads. I'm gonna route them back here behind the hood. Okay, we're gonna go on a test drive. We will watch the voltages we have on those wires. Now, we have the solenoid here. The solenoid has 2 wires. So I'm tempted to also back probe the other 2 wires of the solenoid so we can watch the control, the voltages on the solenoid. Okay, because when the solenoid gets turned on by the computer, the voltage on the pressure switch should change. So I'm gonna back probe those 2 wires. Since we have a 4-channel lab scope, I'm gonna back probe the other 2 wires. We will watch the voltages on those wires too. Okay, I'll get my scope test leads set up, and then I'll bring you guys back up. I got everything back probed. I'm gonna show you the connectors that are back probed, and then we're gonna go on a test drive. So back here, our VTEC solenoid is back here. So the yellow trace and the green trace, the yellow test lead and the green test lead are back probing the switch of the VTEC, and then our blue test lead and our red test lead, we are back probing. I hope you can see right there. Yeah, so these 2 over here are back probing the solenoid itself. Okay, so now let's go in the vehicle so we can look at the voltages on the lab scope screen. So we're gonna back out. Let's go to lab scope. Actually, before we go to lab scope, let's go to service info first. This is a Honda Element. Is this a EX or LX? Hold on, I will look this up. I'll be right back. This is a Honda Element EX. I wanted to look up this code once again on the service info, although we already have an idea about what's going on here, but I want to look it up just one last time to see if there's a TSB about this code, because you never know. So we are on the service info. Our code is P2646, or right here. So this is a pretty common code on these. Variable valve, lift oil control valve. Interesting. So let's click on this. Technical bulletins. Okay, let's see if we have a TSB. Oh, there is. So malfunction indicator lamp comes on with DTC P2646. Let's see what we got here. Revision summary. Possible causes. The rocker arm oil pressure switch may fail intermittently. Corrective action, replace the rocker arm oil pressure switch. Okay, that's good to know. We know that already. Here it shows us the location of where the switch is. So we are back probing the wires at the switch. Rocker arm oil pressure switch. This is the VTEC. This over here is the VTEC solenoid assembly. So right now we are back probing the wires. Let me open this. So what I did under the hood, we are back probing the wires over here at the solenoid and the wires at the VTEC pressure switch. Okay, so now let's go to lab scope. Let's turn on all our channels here. Let's see what voltages we have. The key is on right now. I'm gonna start the engine. The engine is running. We got nothing there. That's odd. Let me refresh this. We don't have a voltage on this VTEC solenoid. Let's go under the hood. Let's make sure that we are making good connection at those electrical connectors. Let me make sure we're making good connection here, because the 00 that I see on the lab scope screen does not seem right. Okay, I should be making good connection now. Let's go back in the vehicle. Same thing. This is odd. This is really odd. So here's what I'm gonna do. Let's go back to our service info and look at the wiring diagram. Those wires that go to the VTEC solenoid, where do they come from? Wiring diagram. VTEC oil pressure control valve, rocker arm, VTEC oil control valve on front of cylinder head, rocker arm oil control solenoid VTEC valve on right front of cylinder head. Okay, so this is it right here. Let's zoom into this wiring diagram. Okay, so according to this, so these over here are our component. VTEC control solenoid valve, rocker arm control solenoid valve. And then where is the switch? So there's a ground wire. Let me highlight these two wires. So it looks like we have a green and yellow on the rocker arm oil control solenoid VTEC. And then we have a blue and white. So let me follow these two wires. So they both come from the engine computer. Interesting. Now, we may not have anything at the valve right now because the computer is not turning it on right now as we're sitting at idle. Oh, here's a pressure switch. Rocker arm, oil pressure switch, VTEC oil pressure switch. So the pressure switch has ground on the brown and yellow, so this wire over here. And then there is a control wire that comes from the engine computer. This blue wire over here, blue and black. So there's ground going to the switch, and I believe there should be voltage on this blue and black wire, which is the signal wire of the switch. As the switch opens or closes, the voltage on that wire should go down. Because right now, if we go to our lab scope, we got no voltage on all these wires. This is very odd. It shouldn't be this way. We should have some type of voltage on these wires. So this blue wire over here, let me just highlight this one wire. So this blue wire, the one I just highlighted, that wire should have voltage coming from the engine computer, because if we follow this wire, it comes from the computer. Okay, VT pressure switch. You know what I'm gonna do? Let's go under the hood. I'm gonna turn off the engine. Let's go under the hood. Let me check those ground wires and make sure I'm getting good ground to those wires. And then we're gonna use a multimeter to check the other wires. Okay, let me turn the engine off. Let's turn the key on. Let's go under the hood. I'm gonna bring the scan tool with me under the hood. I'm gonna disconnect these test leads. So I wanna make sure I'm looking at the right wires. So on the switch, the brown and yellow should be our ground wire. So which one is brown and yellow? Okay, brown and yellow is this one. So brown and yellow was connected to the yellow test lead. Now I'm gonna use a test light. So I'm gonna connect my test light to power. Test light is connected to power. If I touch ground, test light should light. As you can see, test light lights. So let's see if we have ground over here. Okay, so test light lights. So this tells me that our VTEC switch is getting ground, so that's good. So now the solenoid itself, the ground wire on the solenoid is black. So I'm gonna reconnect to this. Now I'm just double checking to make sure that we have good ground going to the switch and good ground at the solenoid before we go on a test drive, because we could have a weak ground or poor ground going to these components. So now I am testing this wire here. Okay. Okay, so that black wire is what I'm about to test. So it is connected to, it's connected to the blue test lead. I'm going to disconnect it. My test light is still connected to battery power. Now I'm going to connect it to the back probing tool. Let's see if we have ground there. So I hope you can see that the test light lights. So this tells me that we have good ground going to the VTEC solenoid. So that's good. Okay, so we are connected. All right, so one thing we know, the VTEC solenoid is getting good ground. The VTEC switch is getting good ground. So now the key is on. The key is on in the vehicle. Now I'm gonna use my multimeter to check the other wires. Check the other wires. So if I touch this, we read battery voltage on the multimeter screen. So I'm gonna put the multimeter here. I hope you guys can see it. So now I'm gonna back probe the other wire on the switch. Okay, so now we're back probing the wire that comes from the computer on the switch. So now I just have to make sure I'm making good connection here. I hope I'm making good connection. Do we have anything there? I kind of don't really trust this. I don't think I'm making good connection on this control wire. I mean the signal wire of the switch. You know what? I'm gonna use I'm gonna use a piercing tool, because that's, for some reason I can't really make connection with the signal wire of the switch. I'm gonna use a piercing tool and then let's see what happens. We're gonna use this piercing tool on the signal wire of the switch. You guys probably won't be able to see this, but I'm just gonna explain to you what I'm doing. Okay, so I'm going to pierce this wire just so I can make sure that we are making good connection, and then when we are done, I'm going to fix the hole that we're putting on the wire with some liquid tape. So I have my multimeter connected to battery ground. I'm going to connect it to this wire. Check this out now. You see how we have 5 volts. What's the voltage? It's bouncing between 5.90 volts and 6 volts. Okay, this is something very important, and I want to mention this. Remember when we looked at the lab scope, there was 0 volts on all our traces. We had 0 volts because I wasn't making good connection. Okay, so because when I was looking at the wiring diagram, the control wire or the signal wire of the switch comes from the engine computer. So it goes from the computer to the switch. If we don't have voltage on that wire, the issue could be the computer not sending voltage to the switch, or an open in the wire between the switch and the engine computer. We were having 0 because we weren't making good connection. So now we double checked with our multimeter. We're now making good connection. So I'm gonna get my multimeter out of the way. Now I can connect my lab scope test lead to this piercing tool. Okay, so this makes me feel better. Now we're gonna test the control wire of the switch, of the solenoid now, because I didn't like the voltages that I had on the lab scope screen. So what do we have here? I hope you can see the multimeter screen. Right now I'm just double checking my connections, because you can misdiagnose something if you're not making good connection, because you can have some misleading results while your issue is just a connection issue. So I'm checking and double checking myself before we go on a test drive. Okay, so now to test this, let me see if I can turn on the VTEC solenoid, because right now we're connected on the control wire. I'm going to start the screen recording, Matt. Okay, so we're recording. So let's go to functional test. I'm going to turn on the VTEC solenoid to see if the voltage on the multimeter is going to increase. If the voltage, because right now we're connected to the control wire. We're connected to the control wire of the VTEC solenoid. So let me back out. Let's go to functional test. VTEC test. This has an automatic transmission, solenoid valve actuation. Oh, perfect. Now, I'm gonna do this. Matt, can you show the multimeter? Check this out. Do you want to repeat? Right now, as you can see, we have 0.01 volt because the VTEC solenoid is not being turned on. So I'm gonna turn it on now. You see how the voltage went up? Okay, and I can hear the solenoid click. So this is good. This tells me that the computer can turn on the solenoid, the wiring of the VTEC solenoid is good. Actually, we may not even need to go for a test drive. We can just do all the testing here in the shop. So now what I want to do is I'm gonna watch the voltage of the switch with the multimeter, and then I will turn on the VTEC solenoid to see if that voltage is gonna change. Okay. So I hope what I'm doing right now is not confusing. So right now I'm reconnecting my multimeter to the VTEC switch. Okay. Okay, let's do it this way. Maybe you can come from this angle. So now I'm gonna go in the vehicle and start the engine, and then we're gonna turn on the VTEC solenoid again. Right now we're gonna see what voltage we have at the switch with the engine running. So as you can hear, the engine is running. Okay, the voltage at the switch is jumping around. I don't really like this. This is not good. The fact that this voltage is jumping around, this is not good. This is an indication of a switch that's failing. So now what I'm gonna do is I am going to turn on the VTEC solenoid. So Matt, you're gonna focus on the multimeter. So here, let me explain what I'm about to do in case some of you have a question. So right now, I'm watching the voltage on the switch signal wire. When I turn on the VTEC solenoid, the VTEC system is gonna open, oil is gonna flow through the system. The switch should see the change in pressure in the VTEC system. And when the switch sees the change in pressure in the VTEC system, the voltage on the switch signal wire should change. Okay, we should see a drastic change on the voltage on the signal wire of the VTEC switch. So the switch should tell the computer, hey, the VTEC system has operated, everything is well. If the voltage doesn't change, if it remains the same, or if it barely changes, that will tell us that the issue is either the switch or maybe there's no oil pressure going to the VTEC system, which I don't think is the case. I believe the switch is bad. So let's check that now. I'm going to, so Matt, you can just show the multimeter screen. I'm gonna turn on the VTEC system. Let's see what happens. We're gonna actuate the solenoid. We have about 6 volts, 5 point. The engine should not be running. Turn the ignition switch off. Okay, so we can do this test while the engine is running. Now, what I'm gonna do is, since we can't do this bi-directional test right here in the shop, we're gonna have to test drive the vehicle and watch the command on the control wire of the solenoid. So I'm gonna reconnect the lab scope test lead to the VVT solenoid, and then we're gonna go on a test drive. We're about to go on a test drive. Now, the first thing I'm gonna do is, I would like to watch my lab scope, the voltages I have on the lab scope. Okay, let me make sure I'm making a good connection here, because okay, so yellow trace, green trace is kind of jumping up and down. The green trace is connected to the switch signal wire. I don't like how this is jumping up and down. Okay, I also want to look at my scan data as we're watching this. So what I'm gonna do is I'm gonna back out. Let's go to data. I'm gonna grab my VTech data PIDs, the PIDs that we were looking at earlier. And then I'm also gonna put my lab scope screen on the screen here. We're gonna look at both screens at the same time. Let's see. We're gonna list these. I'm gonna grab the switch. The switch says on all the time. Okay, so let's go to guided component test. This is how I'm gonna put the lab scope screen and the scan data both on one screen. So here's what we're gonna do. Meter. I'm gonna turn on all these other channels here. So we have about 1.2 volts on the green trace, minus 0.05 volts on the yellow trace. We have minus 0.02 volts on the blue trace, and then minus 0.02 volts on the red trace. So we're going to do this, and then we're going to go to scan data, and then I'm going to bring up our lab scope here. Okay, so we're going to watch the scope as we're watching the scan data on the screen. So let's go on a test drive. I'm gonna put this over here. I'm gonna watch our lab scope screen as we are driving. Actually, the traction control light also came on the dash. Matt, can you show this light over here? Let me see, right there. Traction control light also came on. All right, that's good to know. Our first two traces on the lab scope are connected to the switch. So the yellow trace on the lab scope is connected to the VTech switch ground, and then the green trace is connected to the VTech switch signal wire, and then the blue trace is connected to the VTech solenoid, and then the red trace is also connected to the VTech solenoid. So last two traces on the lab scope are connected to the VTech solenoid. So right now the VTech is not being turned on right now by the engine computer. Oh, whoa. What the heck is that? You can't even drive this thing. Whoa. What the frick is that? Wow. I am gonna stop here. Let's stop here for a second. Matt, did you feel that? It's like the whole car is like jerking. Dang. Okay, so let's rescan this. I don't like how the pressure switch voltage is all over the place.